Hey guys, how you doing? It's Coach Scott and another edition of Coach Scott's Chemistry here on Purple Wave Chemistry. And welcome today. And again, we're doing a Unit 1 test review. And some of the things I went through on the review sheet, just some questions, some things I need you to know about. Let's think about it, right? So one is particle diagrams. There's already a good video on particle diagrams, but we use particle diagrams to understand what's going on the nanoscale. I talked to one of my former students who's now taking AP chemistry, and he said the hardest thing and what they really gathered because they've had this class is they're thinking on what I want to call the nanoscale, the really, really, really small scale of looking at material, right? Looking at stuff. Now, let's think about some ways we can use those particle diagrams to understand some things, right? So let's draw some diagrams real quick. All right, let me get my little draw thing. Okay, so let me get my little pencil. So let's make some boxes. And boy, I can't draw for squat. I think y'all guys know that. So say I was going to let folks understand a little bit, try to explain the difference uh, the difference between a solid and a liquid. All right. So most solids have a density that's greater than 1 gram per cubic centimeter, right? Greater than water. That's why they sink. Now, if I look at like alcohol, it has a density of like, oh, I don't know, 0.878, which is less than water, which means it's or oil, right? Oil has got a density less than water, so it's going to float on top. All right. So how does this particle diagrams using the atomic model of matter? Think about what we're talking about. Account for this difference between like oil, which has got a density less than water, right? Which means it's going to float versus like penny, which means it's going to go on the bottom. So let's think about this. How can we write a diagram to explain that? So okay, so I'm going to put solid and water, and again, a picture is worth a thousand words. Solid in water. Okay. Now, how would I write those diagrams? Well, again, we're talking about particles, atoms, atomos, right? So let's just draw my little solid right here. How are those atoms? Well, they're in a matrix. They're very close to each other. I'm going to do them like that, and I'll do 2 layers here, right? All right. And so this is in water, so I'm going to need to account for the water particles, right? All right, so that would be my penny. Let's do our water particles. Let's use purple for those, right? So water, they're not as tightly in there together, so they're able to flow against each other. They're a little bit more free, a little bit more space in between them, right around that metal, penny. So I don't have to put a certain amount in there, but I've got those real close together. All right, and this lets me see that you understand what's going on with the atomic model or what's going on the nanoscale. Is you got these tightly packed together particles, a solid, surrounded by a liquid, water, right? So a liquid, so liquid in water, in water. Less dense, let's write that down, less dense, less dense than water, which means it'll float, right? So let's put our little water molecules in there, all right, our water molecules, our little water particles. We don't know what a molecule yet is. So I'm doing like that. Again, there's space in between them. They're able to move around each other, right? All right, So that lets me know that I've got water there, right? So we got to express that. And I can do something similar with gas. Do the difference between a solid and a gas. A gas are going to be all over the place, right? So let's put our oil, and our gold is oil. So again, they're able to move freely, but because there's less particles per unit volume, all right, I can space those out a little bit more, and they're floating on top of that water because they're less dense than water. All right, so it's up in there. Okay. Now, say I want to talk about a gas. Let's say there's some gas, and of course there would be. There'd be what, air on top of that. How would we account for that? Let's use blue for that. So air, man, they're all over this place, right? It's, man, they're just not very close together, right? Much less dense than like liquid, much less dense than the oil, much less dense than solid. They're just floating around and flying around. I can even say that they're moving faster. I can put little whooshies on there, two little lines, show that they're moving, right, in different directions, different speeds, all right. Do a small one. So this just lets me know that, boy, they are moving around, they're doing their own thing, all right, and there's not very many on per unit volume, right? Right there. Okay, so this explains what's going on with the atomic model, right? It tells us the difference between a solid, a liquid, and a gas. And I think it's a good thing to know and to come out of Unit 1 knowing this. So anyway, Coach Scott saying good luck and Hullabaloo Connect.